Hey everybody, just want to welcome you to week 9, module 9 for ME111 System Dynamics. A couple of bookkeeping things. Your quiz number 9 has been posted to Blackboard, and this will be due on Friday the 30th by 4 p.m. Also, your homework number 4 has now been assigned. This will be released Monday morning at 6 a.m. and it'll be due on November 2nd, Monday, November 2nd by 11 p.m. Again, please reference the homework guidelines for details on your format, grading, and submission. And a reminder again, my office hours are scheduled for Tuesdays and Wednesday mornings from 9:30 till 10:30 a.m. If this time does not work for you, please email me, send me a message on Teams, and we can find a time that'll work for both of us so you guys can get in, cover any content, questions you have on quizzes, homework, or how this course relates to future courses. So as we take a look at Module 9, we're going to be covering system analysis in the time domain. So by the end of this chapter, you should be able to sketch frequency response plots for a given transfer function and use the plots or the transfer function to determine the steady state response to a sinusoidal input. You should also be able to compute the frequencies at which the resonance occurs and determine a system's bandwidth. Analyze vibration isolation systems and the effects of base motion in rotating unbalance. Determine a steady state response to a periodic input given the Fourier series description of the input. Estimate a form of the transfer function and its parameter values given a frequency response data, and use frequency response methods to evaluate vehicle suspension performance in a case study. And lastly, take a look at MATLAB as an aid for these preceding tasks. So I'll do a couple of problems by hand and go over some of that in the PDFs for your lecture slides, as well as in one of the videos for an example problem. And you'll see how doing it by hand as compared to doing it by MATLAB can take a lot more time. You can save yourself a lot of work and headache, or at least have a double check if you use MATLAB as well. So we'll break this module down a couple different sections. For the first section here, module 9.1, we're going to take a look at the frequency response of first order systems, higher order systems, and a couple applications. So this relates to sections 9.1, 9.2, and 9.3 in your textbook. 9.1 being frequency response to the first order, 9.2 being for higher order systems, and 9.3 being the frequency response applications. So as we go on to the second section here, module 9.2, we'll look at filtering responses of dynamic systems, response to general periodic inputs, system identification from frequency response. And relating to our textbook, this is 9.4, 9.5, and 9.6. 9.4, looking at the filtering properties of dynamic systems. 9.5 covers the response to general periodic inputs. And 9.6 is system identification from frequency response. So that brings us to the last section, module 9.3, where it's MATLAB review and a little bit of a case study. So 9.7, there's going to be a case study. We're going to look at the vehicle suspension design. 9.8, we're going to do frequency response analysis using MATLAB. See how this can save us a little bit of time, work as a double check for us, and just a little bit of an overview for the review of the chapter and what we covered.